In this video, we're going to learn about galvanic cell. The other name for galvanic cell is voltaic cell. To construct a galvanic cell, we need to have two components. The first one, we need to have the electrode. Right here, this is the example of an electrode. The electrode should be in solid form. And right there, the second component that you need to have if you want to build a galvanic cell, you need to have the electrolytes. And they need to be in aqueous form. Another thing that you need to know about the electrode is the electrode potential, which is defined as the potential difference produced between the electrode and the solution in the half cell. You have a solution over here. When you get this electrode and you stick inside the aqueous solution, it will create a potential difference. For a galvanic cell, it will be applying the concept of redox reaction. Redox simply stands for reduction and oxidation. So we need to know three important things about redox reaction. The first one is about the electron. The second one is about the oxidation number, and we need to know about the reaction will happen at which part of the galvanic cell. Down here, I have provided for you two pictures, and both of them are representing a very useful mnemonic in which you can use them to help you to remember where is the reduction going to be and where is the oxidation going to be on your galvanic cell. For the electron, what happened for reduction process, that is the gaining of electron process. Whereas for oxidation process, that is the process of losing electron. And what about the oxidation number? For the reduction process, the oxidation number will decrease. And for the oxidation process, the oxidation number will increase. Note that oxidation number. So if you have oxidation process, it will favor the oxidation. Therefore, oxidation number will increase. So where will the reduction and oxidation going to be taking place in your galvanic cell? So the reduction process will be taking place at the cathode of your galvanic cell, whereas the oxidation process will be taking place at the anode's half cell. So remember that I tell you just now, I did tell you that the two pictures that I have provided for you in this video representing a mnemonic that can help you to remember the process better. And how we're going to use these two pictures to help you to remember reduction is going to happen at cathodes, oxidation is going to happen at anodes. So some useful tip, when you remember this picture over here, please remember red cats. If you can remember red cats, you can imagine red cats, you will be able to recall the information that this process over here is representing reduction, red, at cathode. cats. Red cats. Remember red cats. Remember reduction happens at cathode. So if you can remember reduction is taking place at the cathodes, automatically you will be able to remember that oxidation will take place at the anodes, because reduction and oxidation, they are the opposites of one another. What about the second picture that we have over here underneath the red cats? This is the picture of an oil rig. And how are we going to use this mnemonic to help you to remember some information? So when you look at the letter O, you can imagine that one is oxidation. Okay. And I over here is, and L over there is losing. Then you're going to add information, electrons. Okay, so oxidation is losing electrons. What about rig? Rig is, that one is reduction. And I again is for S, and G is for gaining, and that one refers to the gaining of electrons. That's how you're going to use these two mnemonic to help you to learn about the process in a galvanic cell. Oil rig, oxidation is losing electrons. Reduction is gaining electrons. Red cats, reduction at cathode. So let's have a go with these two half cell equation. So these are, I'm going to introduce to you, these two over here are known as the half cell equations. So the one in purple, what do you think this one representing as? And the one in blue, what do you think this one is going to be? Is it going to be reduction, or is it going to be oxidation? Look at the position of the electrons. For the one in purple, the electrons is at the products side. And on the blue bits over here, the electrons is part of the reactants. So this is the process of losing electrons. So this is the process of losing electron. Okay. So I'm going to use yellow. So this is a process of losing electrons. So who will be losing electrons? If we go back to the mnemonic, oxidation is losing electrons. Oxidation is losing electrons. Therefore, this part over here is oxidation process. And the one in blue, this one is gaining electrons. Okay, so you have gaining electron process because you are receiving electrons over here. And this is obviously will be your reduction. So this one will be your cathode because red cats, that's how you're going to remember that. Okay, reduction is gaining electrons, red cats, and automatically the one oxidation here, this is here, this is your anode. Now, in the whole chapter of electrochemistry, you need to know two cells. And for a galvanic cell, it will be the process of converting chemical energy into electrical energy. Okay, so the process of converting from chemical energy into electrical energy, this is for the galvanic cell. And we say that this process over here is a spontaneous reaction. Why? Because we do not have to supply electrical energy to get the electron to jump from anode to cathode. The one that we have down here, that is for another cell known as electrolytic cell. And we're going to look at this electrolytic cell in another video. And I think you can guess it already. This one will be a non-spontaneous reaction. Why? Because you need to convert electrical energy into chemical energy. In other words, you have to supply electrical energy in order for you to get the electrons to move from one spot to another spot. This is a typical galvanic cell. You have two beakers, you have a salt bridge, you have your electrode, anode, cathode, you have your voltmeter or galvanometer connected to the electrodes through wires over here. The electron will flow from anode to cathode. Okay, remember, the electron will flow from anode to cathode. Why? Because anode is the negative terminal and your cathode is your positive terminal. And how are you going to remember this? Remember, look at the word cathode. Cathode has the letter T, and T looks like positive. Therefore, cathodes will be the positive terminal. Okay? And then the electron will flow from a place that is a lot of electrons. So they're going to be jumping from a place with a lot more negative towards somewhere that is less negative. So you can see that the electrons will be moving spontaneously. So you don't have to supply extra electrical energy to get the electron to flow from anodes to cathodes. Okay, now let's learn how to draw the galvanic cell in 6 steps. Step number 1, you have to draw the 2 beakers first. And then in step number 2, you have to draw the 2 electrodes. We have anode, negative terminal, cathode, positive terminal. Remember, in the cathode word, you have the letter T. And letter T looks like positive sign. So that's how you're going to remember which one is going to be negative, which one is going to be positive. A little tip for you right there. And then step 3, you have to draw the electrolytes inside the 2 beakers. In step 4, you have to connect the electrodes with a voltmeter. You have a voltmeter like this. This is the symbol for voltmeter in the syllabus of matriculation. You have to do it like this. And then you have wire connecting all of them. And then in step 5, we need to draw the salt bridge to connect and to complete the whole circuit. The function of the salt bridge is to maintain electrical neutrality. In step 6, you have to draw the electron flow from anode to cathode. Remember, the electron will flow from anode to cathode. So step 1, you draw the beakers first. You have 2 beakers over here. You're going to draw them first. And then followed by step 2, draw the electrodes. You have your anodes on your left and you have your cathodes on your right. Okay, remember, anodes, cathodes. And then step 3, draw the electrolyte. So those are the electrolytes, the one in aqueous phase. Your electrode over here, anodes and cathode, they are in solid phase. Step 4, you're going to be connecting both of the electrodes or the half cells over here. This is the anode half cell. That is the cathode half cell with a voltmeter. It's compulsory for you to draw it like this, and you need to write it, the voltmeter, down there. And then in step 5, draw the salt bridge. Okay, so the salt bridge will be completely immersed in the electrolytes like this. Okay, you have the salt bridge, and you need to label your salt bridge. And finally, you have to draw the flow of the electrons. Okay, you have it from anode, flow to cathode. Why do you have the arrow in the voltmeter going that direction? That is because your electron is moving from anode to cathode. Okay, anode to cathode spontaneously without supplying extra energy from outside. So some tip, if you want to remember how to draw the galvanic cell, you can use the ABC trick, okay? A, B, C. I'm going to highlight that for you. A, B, C. One more time. From left to right, A, B, C. If you have it the other way around, it's still going to be A, B, and C. And the electron will always going to flow from anodes to cathode. So if you have your anode right here, the electron will flow that direction instead. Okay? So that's how you're going to draw the galvanic cell. Now, let's try to draw some galvanic cell by using 2 questions. Over here, this one is a very straightforward type of question because it gives you which one is the cathode electrode, which one is the anode electrode, which one is the electrolyte for the cathodes, and which one is the electrolyte for the anodes. And you have the salt bridge over here, which is KCl. So you're going to draw the same type of galvanic cell, but over here, since we have specific anodes and cathodes and the electrolytes, you have to write it there. Okay, you have to label that. So we're going to try to label the anode first. So if you go back to the screen over here, you have copper cathode. Okay, we have copper cathode over there. I'm going to try to do that one first. You have copper cathode, and another anode is zinc anode, the electrode. So we have zinc and copper. So zinc will be at the anode. So zinc will be here. So you're going to write that. So here you'll have zinc solid. Okay, so you have to write together with the face. Now you have zinc solid. Okay, so that is the zinc solid. Point to that electrode. And you have copper cathode. So copper will be copper solid. Okay, together with this whole thing right there. Okay, point to that electrode. And next, what you need to do is, now we're going to do for the electrolytes. We have copper sulfates. That is the electrolyte for your copper solid. Okay, so I'm going to write that, so that should be together. And we have zinc sulfates, and this is going to be the electrolytes for zinc solid. Okay, so that should be together. So we're going to write the electrolytes of copper sulfates for the cathode. Okay, we're going to use purple. We have 1.0 molar CuSO4 aqueous. I'm going to highlight that for you and point that into the electrolytes. In there, you should having Cu2 plus aqueous and SO4 2 minus aqueous. Okay. The other one, here you will have 1.0 molar zinc sulfates aqueous, and point that whole thing to here. So in there, you'll get zinc 2 plus aqueous and SO4 2 minus aqueous. Okay, so what about the salt bridge? For the salt bridge over here, you also need to label that. Okay, so the salt bridge, you have KCl aqueous as the salt bridge. So if you go back here, so we're just going to use yellow. So the salt bridge will be KCl aqueous for the salt bridge, and label that. And the K plus, okay, so you have the K plus, aqueous will go to that direction, and the Cl minus aqueous will go to that direction. Okay, why do you have the Cl minus aqueous going to this half cell and K plus going to this half cell? Because you want to maintain electrical neutrality. As the electrons are moving from anode to cathode, this cathode half cell will be getting negative and more negative, and to maintain electrical neutrality, to get the electron to keep moving to the other side, the K plus ion from the salt bridge needs to go to the cathode half cell. And the same thing will happen over here. Since your anode half cell over here for the zinc half cell is losing more and more electron, and to maintain the electrical neutrality, the Cl minus from the salt bridge will start to migrate to the electrolytes of your anode's half cell. So this is how you're going to get full mark for your drawing for a galvanic cell. Let's try another questions over here. So this one is a little bit more not so direct kind of question. It gives you a overall cell reaction. Okay, we have overall cell reaction, and it wants you to draw a complete galvanic cell, voltaic cell, if the half cells are connected with this salt bridge. Okay, so you have another type of salt bridge, and the electrodes are immersed in 1.0 molar electrolytes respectively. And we need to state the function of the salt bridge. So before you're going to do this, you need to identify who will be at the anode's half cell, which will be undergoing oxidation, and who will be at the cathode half cell, which will be the reduction process. So you look at your overall cell reaction. When you look at the aluminium over here, what happens to the aluminium on the other side? It will become 3+. So this aluminium in the beginning in solid phase will be turning into aqueous because it loses electrons. So aluminium will be losing the electrons, and lead, Pb over here, lead will be gaining electrons. Look at the reactant side, your Pb2+, okay? So when the 2+ disappears to become Pb solid, to do that, your lead 2+ needs to receive 2 moles of electrons for the 3 mole of Pb right here. Okay, so the aluminium will be losing of electrons. The lead over here, Pb, will be gaining electron. So now you can guess that for the anode half cell, oxidation, losing electron will be for the aluminium. Okay, so the aluminium will be losing electrons. Okay, so you will have the losing of electrons process. So you have lost electrons over here, therefore aluminium will be at your anodes. And the cathode will be your lead. So the lead will be undergoing reduction. Reduction is gaining of electron. Remember, rad cat, reduction at cathode, reduction. Oil rig, OIL, oxidation is losing. RIG, reduction is gaining electrons. So you can use these 2 mnemonics to solve this, to identify who will be the anodes and who will be the cathode. Okay, so your electrode right now. So the electrode that we need to have. So the electrode, you have aluminium solid and lead solid. So that is the electrode. And that is the electrode as well, because you have solid and solid. So what happened? You have the electrode, aluminium solids at the anode, and you have the lead solids at the cathode. And the electrolytes, okay, so the electrolytes is this and this. So that is the electrolytes, and you have electrolytes. And this is how you're going to draw the galvanic cell for the question. So you have the electrolytes labeled. This time we do not know what is the other part of the electrolyte, so it's enough for you to write it in Al3 plus aqueous. You don't have to write the stoichiometric coefficient over here. You can just simply write Pb2 plus over there. Okay, so Pb2 plus will be the cathode. Okay, Pb2 plus in cathode. So you have it that in cathode here. So that is the cathode half cell. Lead. Okay, electron will flow from anode to cathode. Make sure you have electron flow from anode to cathode. And the salt bridge, KNO3. So you have K plus aqueous going to the cathode half cell, okay, to maintain electrical neutrality, because your cathode half cell will be getting negative and negative. And then your NO3 minus aqueous will be going to the anode half cell, because the anode half cell over here, the aluminium half cell, will be getting more and more positive, because you're going to start to lose electrons. So this is how you're going to be doing the questions over here. Now let's a bit more challenging if you will, but it's quite easy if you apply the mnemonic, and you can do it in this way. So now, the function of the salt bridge is simply to maintain electrical neutrality, by completing the circuits.